All right, 6.2, number two. Number two. Now, this new problem is remarkably like the old problem. You're on a skateboard, you're throwing your pet, but there is one critical difference. In this case, you're not on a skateboard that's standing still, but your skateboard is moving forward at your maximum velocity. So you're moving forward, and as you're moving forward, you're throwing your pet forward at the maximum speed relative to your motion. So this chicken's not moving at 19 meters per second. This chicken's moving even faster because before I threw it, I was already moving. So the question is not how fast the chicken's moving. That's easy. The question is, how fast am I moving? And we're going to try to film this. I'm a little worried because it looks like the tripod that's holding the camera might fall over. But we're going to do as much as we can, and hopefully we'll get through this without the tripod with the camera falling over. So let us get started. Now, the chicken and I, initially, in your case not a chicken, are moving as one. Now, I'm going to do something a little different from what we did last time. Here, we have the mass of me, the velocity of me, the mass of the chicken, the velocity of the chicken. Now, if we're all moving at once, could I do something like this where I could say, we have our initial velocity times my mass plus the mass of the chicken? Isn't that the same thing? Where we have the same velocity, in both cases the velocity is the same, right? And we're just kind of moving them in front. So, you may have done this already in math class. Most of you are probably like, oh yeah, I've done that a million times in math class, that's fine. But I want to make sure that's okay with you first, all right? So that's what we're doing here. So we're going to say this combined mass of me and the chicken is moving at this velocity. But once I throw that chicken, we're going to be separated. We will be my mass times whatever my final velocity is, the final velocity of merit, plus the mass of the chicken times. Now, here it gets tricky because I'm throwing it 19 meters per second faster than we were moving when we were already moving. We're not 19 meters faster than zero. It's 19 meters faster than my initial velocity. So it's 19 meters per second plus my maximum velocity, which, by the way, is my initial. Well, let's put in there. Let's put in there. Okay. V chicken thrown plus velocity initial, right? Okay, just using nomenclature here. Okay. So my initial velocity. Now the fastest speed I can go is 5.6 meters per second on foot. My mass is 108.9 kg. Plus the chicken comes in at 3.2 kg. And this is going to equal my mass, 108.9 kg, times my big unknown, how fast I'm going to be going at the end. That's the big unknown right there. Plus mass of the chicken, 3.2 kg, times. Okay, so here's our thing here. The velocity the chicken is thrown is 19 meters per second, plus the initial velocity, because the chicken was moving even before being thrown, of 5.6 meters per second, and I'm out of board. By the way, I keep forgetting, in all cases, the direction is that way, right? That way. In this case, the direction is that way. I'll make sure I keep those in here, but I really I don't have enough space, Not enough space. All right, let's start making some space by adding some things together. 5.6 meters per second times 108. So times, let's see, 108 plus 32 is 112.1 kg. And that will equal 108.9 kg times VMF. That's still our unknown. Plus 3.2 kg times 19.5 times 5.6 is 24.6 meters per second. And of course it's that way. Try to get those in here, but again, we don't have a lot of space. It's all that way. Let's move. All right, now 5.6 times 112.1. You multiply it together and you get 627.76 kg meters per second that way is equal to 108.9 kg times our big unknown, the final velocity of merit, plus 3.2 times 24.6, we get 78.72 kg meters per second that away. Everything's that away, right? So, gonna go through, gotta subtract, and take my little cheat sheet here. Gotta subtract 78.72 kg meters per second that way from both sides, minus 72.72 kg meters per second that way. Now, by the way, the units make a big difference. You can't subtract apples and oranges. Not only do the units make a big difference, the direction does. If I'm going to subtract these, I have to make sure that they're both the same direction. Well, what happens? They are both in the same direction, so that makes it pretty darn easy. So subtract that, and this goes away completely. Over here we get 549 kg meters per second that way is equal to 108.9 kg times our big unknown, the final velocity of merit. Okay, we're almost done here. Divide both sides by 108.9 kg. 108.9 kg. They cancel. Kilograms cancel, but the other units remain untouched. And what do we get? I get 5.04 meters per second that way is equal to the final velocity of Mr. Merritt. By the way, we're going to end up rounding that to 5.1 because we only have two sig figs. So 5.1 meters per second that away is equal to the final Merritt velocity. Now, you may notice something here. This did not send me hurtling backwards. I started out at 5.6 and I was reduced to 5.1. It didn't slow me down a heck of a lot. Why? Because I'm throwing a chicken. Throwing a chicken doesn't do a whole lot when compared to the body as big as mine. Now, quick question. How is this going to relate to your numbers? Well, there's all sorts of things to think about. One is, how fast were you going originally? If you've got a very large animal to throw, it's going to drop you down. Now, one thing's for sure, whatever you're throwing, it's going to slow you down. If you get a number that's bigger than the number that you started at, there's a problem. Because there's no way you're going to throw a chicken and it's going to speed you up, is it? Is there? There's just no way it's going to happen. So it's going to slow you down. How much it slows you down, it's going to depend on a number of things. You know, the bigger your animal, the more you're going to be slowed down. The slower you're going, the slower your final numbers. If you're just barely creeping along at a walking pace and you throw a pony, That might be enough to even put you into negative numbers. It all depends on your numbers. And I want you to think about the numbers. Look at the numbers. Do they seem right to you? Do they make sense? Anyway, there you go. I'll see you later. Bye-bye.